Welcome to The Explainer. So today, we're tackling a problem that anyone doing serious research knows all too well. And it's a frustrating one: total information overload. We're going to dive into a genuinely fascinating framework called PaperFlow. It's designed specifically to solve the headache of that endless daily paper stream, but it does it with an AI that doesn't just hand you some static list of recommendations. Instead, it actually dynamically adapts to how you, a real human researcher, actually read and learn over time. Okay, let's just get right into it. Imagine the crushing daily stress of the scientific publishing avalanche. You wake up, grab your coffee, check your feeds, and boom, there are literally thousands of new papers uploaded across your fields of interest. How do you possibly keep up? I mean, you have limited time, so you have to skip things that look perfectly plausible just to survive the day. And worst of all, what you care about today might be entirely different from what you cared about, say, a month ago. To really put this sheer scale into perspective, let's look at a number straight from the benchmark data in our source material: 497,448. That is the number of episode paper records that a simulated researcher has to somehow filter through over just a 50-day period. Nearly 500,000 potential papers. So navigating this whole shebang isn't just about finding what's relevant, it's honestly about ruthlessly filtering out the noise on a daily ongoing basis. Section 1, the daily paper avalanche, filtering the noise. Section 2, why static systems fail. The drift blindness flaw. So you might be wondering, why are our current tools letting us down so badly? Well, let's contrast the old way with the new way. Paradigm A treats reading like a one-off task. You give the system your interests, it turns them into this opaque black box embedding, and it just spits out a static ranking. And if you want it to change, you usually have to provide some high-effort, explicit feedback. Now look at Paradigm B. This is the PaperFlow way. We're talking about dynamic daily loops with structured, updatable profiles that actually evolve based on your implicit natural behavior. The traditional static pipelines actually suffer from a fatal flaw that the authors call drift blindness. Because they rely on static embeddings, they completely fail to notice when your research focus inevitably changes over time. But PaperFlow introduces a fine-grained loop. It uses explicit, verifiable logic to track your cognitive drift, and it does it without demanding that you constantly click like or dislike on every single paper you see. Section 3, the PaperFlow solution, a dynamic daily loop. This framework is literally designed from the ground up to mirror how real humans read. The crucial point is captured perfectly in this quote from the source: transforming implicit reading behaviors into explicit, structured logic to enable precise, white box tracking of long-term cognitive drift with zero interaction burden. Honestly, what a massive breakthrough. The system tracks what you read and what you skip entirely naturally. It updates your profile transparently, in a white box way, without ever demanding constant manual feedback from you. So, mapping out the complete blueprint of how this works, the system kicks off by fusing metadata from sources like arXiv and OpenReview. From there, it loops through profile updating and feedback learning. If you read a paper, or even if you just skip one, the AI senses this. Then it closes the loop by actually generating a custom reading report for you and updates your profile for the very next day based on those exact interactions. It's a continuous, living loop. Section 4, Profile, Recommend, Adapt, the 3 course stages. It all boils down to 3 tightly coupled stages. Step 1 is profiling. Instead of a hidden, mysterious algorithm, you get a structured, inspectable profile. You can actually see exactly what the AI thinks you care about. Step 2 is recommending. Here, it uses multiple signals to rank today's papers under a strict budget, say, just giving you the top 20. And finally, step 3 is adapting. It updates your state based purely on what you select to read and what you skip over. That is how you turn a static AI into a living, breathing research assistant. Now, a major key to that adapting phase relies on a concept called interest drift. Think of it this way: if you were deep into researching natural language processing yesterday, but today you read one single paper on AI agents, are you changing your whole career path, or are you just satisfying a quick curiosity? PaperFlow specifically tracks behavioral evidence to distinguish a short-term exploration from a sustained, long-term migration of your interests, and it adapts its future recommendations based on that distinction. Let's walk through a day in the life of a PaperFlow user to see this in action. First, a scholarly profile is generated. Let's say it's focusing on NLP and RAG. Second, the AI pushes out a filtered list of 20 papers out of the 256 published that day. Third, The user simply replies with a few paper numbers they actually want to read. That's the feedback. No complicated forms. Finally, the AI generates deep reading reports for those specific papers and, crucially, updates the context for tomorrow's push. Section 5. Testing PaperFlow. Rigorous benchmarks. But the real question is, does it actually work better than what we already have? To test this out, the researchers set up a highly rigorous benchmark. They didn't just test one type of user. They simulated 24 incredibly diverse researchers across AI, biology, and physics. They ran them through 50 daily paper streams, resulting in 1,200 user day episodes. And this is important. They froze the daily paper polls and enforced a strict temporal order, meaning they ensured there was absolutely zero future information leakage. The AI had to learn day by day, no cheating allowed. And the results? Well, they are incredibly telling. When we look at the metric comparison, in overall recommendation score, PaperFlow hit 55.31, beating baselines like Scholar Inbox. But the real kicker here is the selected NDCG at 20 score. It hit a massive 70.88, compared to Scholar Inbox's 33.47. So what does that actually mean for you? It means PaperFlow doesn't just blindly guess what's broadly relevant to a topic. It is remarkably accurate at predicting the exact papers a researcher will actually choose to read on that specific day. The interest drift analysis visually proves exactly why this system is so accurate. It shows that full PaperFlow just completely dominates the baselines when your interests change. It successfully suppresses those stale, older topics you frankly no longer care about and rapidly adapts to new ones much, much faster than algorithms that are stuck using fixed profiles. Oh, and they didn't just leave it at simulations either. They ran a real user pilot study with 5 computer science graduate students over several interaction rounds. The human researchers found PaperFlow significantly better than their static profiles or daily emails. It achieved the highest precision, the highest actual read rate, and scored a solid 4.0 out of 5.0 for overall user satisfaction. Real people testing it out and loving the results. Which leaves us with a pretty powerful thought to end on today. We've just seen how tracking implicit reading behaviors and updating structured profiles day by day completely changes the game for managing information overload. So ask yourself, as your own curiosity evolves and your research interests inevitably drift tomorrow, will your current AI be ready to follow? Thanks so much for joining this explainer, and we'll catch you next time.